Here is the riddle for you. What you see here is a link expression sitting somewhere in code, obviously filtering transfers by their execution time. And here is the corresponding SQL query executed on the database. The where clause looks the same as in link. The query only retains rows with the executed at field greater or equal to the parameter value. All looks fine, right? Well, that depends. The timestamp in link is not a value. It is an instance of a reference type. This reference type has custom comparison operators defined. That explains why the link query compiles in the first place. The expression you see in link to entities query translated to SQL by EFCore. Now comes the puzzle. How on earth did EFCore know how to translate the comparison into SQL? Operator overloads are just methods. They are definitely not expression trees which EFCore expects or otherwise cannot generate SQL. But don't worry if this looks like magic to you. You're not alone. In this video I will teach you to make that magic with your custom types too. EFCore will follow your intentions and instructions to the letter, producing correct SQL code. But to be able to produce effects like this one, you will have to understand how and, more importantly, why this example works. So we begin with that link query in C# code. The subject of the query is some transfer object. It represents a money transfer recorded in the database. And the filter is expressed with this comparison. Only retain transfers with their executed at property greater or equal to some timestamp object. Object is the key here. This entire where clause operates on objects, not on some timestamp values. So let's take a look at the transfer class. In this video, I'm only interested in the executed at property. The value of that property is an object that represents a timestamp, not a timestamp value itself. Why so? Why didn't I just put a date-time value here and keep all those fancy EFCore mappings away from my codebase? The answer is simple. I insist on doing proper object-oriented and functional design in my C# code. The timestamp record is enforcing an important invariant. All timestamps must be recorded in UTC. How will that work? Here is the value converter that helps EFCore map a timestamp object into a datetime2 value in database. Mind that values loaded from the database restore the UTC kind back. Here is the DB context configuration. Mapping a timestamp simply gives the database column type and the value converter to use. Simples. But then let's ask the same question again. How does this where clause translate to SQL? Seriously. Speaking of C#, the timestamp object does a lot of magic for us. It overloads custom comparison operators which let us compare two instances of this record directly in code. That explains why this link expression in C# compiles. But then how does EFCore translate this comparison into a SQL query? Well, I'll tell you straight. It does not. I will demonstrate that in the most reckless manner that comes to my mind. Instead of comparing any values, I will throw an exception from inside the greater or equal operator overload. This where clause is calling that operator overload and it should throw, right? Let's try and see. I'm preparing to run the application, running it, and nothing bad happens. The application has produced the output just like it did before. And the query is perfectly right. It turns out that this code I wrote in the timestamp record has nothing to do with how EFCore will write the SQL code. And why didn't the application break? Well, that is because this operator never really executed. It would certainly be of use if I ever compared timestamp instances in some algorithm I implemented. But I don't have any such algorithm implementation in this demo, and that explains why the exception never happened. Link to entities expression is just the expression tree EF Core will examine to write the corresponding SQL code for the database query. You will see how that works when I write my own translation process for EF Core. So far, it is only important to understand the backing idea. Left operand translates to a database field, right operand translates to a property of the incoming object, which will be the query parameter in SQL. This new demo method will also query the transfers from the database, but this time by the money amount inside of them. The query begins just as the prior one by telling to pick transfers and to filter them by some criterion. We want all transfers with the amount greater or equal to the minimum money amount indicated with the method parameter. And that is where accidental complexity sneaks in, because we cannot just compare money amounts. We must first ensure the currency codes match. Only then comes the amount comparison as the secondary criterion. The query is done and EF Core will have no trouble to translate this into SQL. But a programmer in me is complaining. In an application swarming with queries that include money, I suspect I will have to write this same expression 100 times at least. I want something better. I want an ability to just compare money instances, just the way I would do that in a spoken language. The code does not compile, and that is a good thing. The first problem is in how the money type is defined. Its job is to preserve invariants regarding money, most notably the number of decimal places that is defined for the assigned currency. But money does not support arithmetic comparisons. This method will implement the greater or equal operator expected by the query I already added over there. If you know algebra, the greater or equal operator defines so-called total order. But the order of money instances can only be partial because two instances must have the same currency. And for completeness, I must define the other three comparison operators. This completes the C# side of the model. The link expression will magically compile now, but again it will never call that method at runtime, because this is another link to entities query that only gets translated to SQL rather than executed. The application would subject this where clause to translation and fail, because EF Core has no clue how to compare money instances in SQL. But I have a surprise for you. In this namespace queries within the data namespace, I have provided information to EF Core just how it should translate money object comparison to plain SQL. And my expression will magically translate to a database query. Can you imagine that? I will now show you how these helper classes are implemented, and with that this demo will be complete. But before we get to that point, I must steal a moment of your time to remind you that there are plenty of videos on my channel, including this video, and all of that is free for everyone, but only thanks to the patrons, the people who are sponsoring this channel on my Patreon page. If you like what you have learned from this video so far, then please consider joining the growing community of patrons on my Patreon page. As a patron, you will get the source code for this video and all other videos on my channel, as well as access to some discounts I occasionally post on Patreon. Thank you for your support. Now let's focus on code again, where I will show you the classes that make EF Core translate your custom C# code into valid SQL. It all begins in this file, which contains two classes. There is a whole bunch of objects with very long type names here, but don't freak out yet. It all begins with a query translation preprocessor factory. My custom factory will be specialized to queries on the money type. Any such factory you provide must implement this interface. That is the interface you will register for dependency injection, and it will be your tool to modify how EF Core translates C# code into SQL. All the factory will ever do is to instantiate the true query translation preprocessor. It must derive from the built-in query translation preprocessor from EF Core before adding its own stamp to the process, but the implementation will typically be trivial. Your custom preprocessor will almost certainly delegate the gruesome part of work to a custom expression tree visitor. So it is the custom expression visitor that will do the real work. Welcome to the bottom. There is nothing below this point in EF Core. This is the lowest level of EF Core query translation, so take a moment to enjoy the view of it. This visitor implementation looks cryptic, and it is cryptic, but its inner working is surprisingly straightforward. It is only interested in handling binary nodes that compare money instances. Therefore, inside the visit binary override, it first dismisses the negative cases. If it's not a comparison defined on a money type, there is nothing to do here. If it is not a comparison operator we are sensitive to, then there is nothing to do here either. And nothing to do means to transfer the work to the base implementation so EF Core can apply its normal workflow to whatever there is in this expression node. Past the guard, the true work begins. The visitor must isolate a left and right argument to the comparison. It will do so by letting EF Core process the left and right subtree in order recursively. If you like recursive definitions, you will surely think you're in heaven by now. And then comes the true transformation of the expression tree. This visitor is supposed to generate a comparison that ensures that currency codes are equal and amounts compare as requested. That is two comparisons joined by the AND operator, hence creating the short-circuiting and also expression node. The two sides of the AND operation are the equal node that performs equality comparison on currency codes from left and right, and the binary comparison on the amount. If you remember how I shown that the actual operator overload is not invoked in C#, this line of code is precisely where that happens. The rest of the code is just infrastructure. You can pause the video to inspect this code, or you can do the same thing I did while preparing this video. Just ask Claude to write this for you. This is where most of our job ends, coming up with the idea of comparing money instances to the database content directly. We come to the final demonstration at last. I'm running the code and waiting to see how EF Core has filtered money transfers by the amount. There are a total of 5 transfers in the database in 2 currencies. Then comes the query, where I can clearly see the equality of currency codes, and then greater or equal applied to numeric amounts. That is precisely as my C# code has stated it, and EF Core has translated that expression into SQL. That is all I ever wanted in this application. Remember the process. First, I have written the query manually, poking out the properties from higher order classes. Then I have remembered that I will have to repeat that manual work in 100 other places in the code base, which I didn't even want to consider as my reality. Then I came up with an idea of extending EF Core to support query rewriting that operates directly on money instances. Finally, I unleashed the powers of Claude to finish the implementation, and it all worked magically on first try. What else could you wish for when developing software?